In this video, we are going to look at something called graph coloring. So the first thing we're going to do is motivate graph colorings. In other words, we're going to talk about why we would care about graph colorings. We're going to define what graph colorings are. We are going to define the chromatic number, which is a number that's related to graph colorings. And then we're going to look at both graph colorings and the chromatic number on an example graph. All right, so let's pretend that we're in a situation where we're coloring a map. And usually when we color a map, we want to, especially a map where we have some kind of landmass that's subdivided into certain areas, like different countries, different provinces, or different states. We want each of those to have its own color so we can more easily identify it. Well, how might we do this in a way that's going to be reasonable? Well, first of all, we would not want bordering states to have the same color. If we did, they might look like the same state, right? So if we took California and Nevada, made them the same color, they'd look like they're the same state. This isn't necessarily true. Maybe you want to use a lot of colors in your map, but let's say also that we don't want to use too many colors. Maybe we don't have that many colors available, or with the colors available, there are only a certain number of colors that are appropriate for that map. So it turns out we can look at this problem from a graph theory point of view, from the point of view of being a graph. So if we're talking about, say, states on a map, the countries or provinces or states, those we would consider the vertices. And if we want to know which pair of states, which pair of vertices would form edges, those are going to be the states that border one another. So the countries, provinces, and states, those are our vertices. The edges are the borders between the vertices. So now I want to translate the coloring of the map into the coloring of the graph. Well, what we want to do is we want to, first of all, color the states, countries, provinces. So those are the vertices. So we're going to color for the vertices. And we want to do it in such a way that adjacent vertices, the ones that share a border, have different colors. And we want to use as few colors as possible. So here's our definition of a graph coloring. Let G be a graph. A coloring, or if you want to be extra careful with your language, a proper coloring of the vertices of G is an assignment of colors to each of the vertices of G, such that each pair of adjacent vertices have different colors. And the chromatic number of G, this is the one that's going to tell us how few colors we can get away with. That is called chi of G. That is the fewest number of colors for which a proper coloring is possible. So you can denote the colors in any way you can. You can literally color the vertices if you're a very color-oriented person, or you can just identify them with numbers. I'm actually going to do both in the examples in this video. So here we have a perfectly nice graph, and we want to see how we can color it. Well, here's one way that we can properly color it. We can give A the color 1, and the color 1 is going to be black, so it's already that color. We'll color B to be 2, and the color 2 we're going to call blue. Our red color is going to be, not our red color, our yellow color is going to be 3. You can hardly see it, that's our C. Our D is going to be green, that's our color 4. And that E we're going to make color 5. And that gives us a proper coloring with 5 colors. And of course that's pretty lame because, and what this tells us is that anytime you have a graph, you can easily find a proper coloring by just coloring every vertex a different color, right? But of course we can do better, right? So I'm still going to let A have color 1, which is black. I'm going to color B with color 2, which is blue. C has to have a different color. That one's going to have color 3, which is yellow. But D, I'm not going to make a new color. I'm going to make that one black again. That's color 1. And then E, I'm going to have color 2. And when we do that, it looks like we can get away with 3 colors. So I have a proper coloring with 3 colors. Now the question is, can we do better than 3 colors? Can we get down to 2? Well, it turns out the answer is no, but in order to determine that with certainty, we got to prove it. So our theorem is the chromatic number of the graph that we had in the previous slide is 3. All right, so in order to prove our chromatic number of 3 is 3, we have to actually prove 2 things. First of all, we need to prove that we can actually color the graph with 3 colors that we already, and then we also have to prove that we cannot do it with 2 colors. right? So that'll tell us that 3 is the fewest number of colors that we can get away with. So we already proved the first part. We already proved that we can get away with coloring the graph with 3 colors. We in fact showed exactly how, at least one way that we can do it. Now we need to prove the second part, in other words, that we can't color the graph properly with 2 colors. So as you might imagine, when we say we can't, if we want to prove that we cannot color the graph with 2 colors, it looks like we're going to be using a proof by contradiction. So we are going to assume for contradiction that we can color the graph with 2 colors, and then we're going to find a contradiction. And the colors, again, I'm going to use numbers, but we'll show the numbers using colors, but I'm going to call the colors color 1 and color 2. So we got to color the vertex A with either 1 or 2. It doesn't matter. If we color it with 1 and get a coloring that works, it's the same, exactly the same as if we flip 1 and 2. So I'm going to just say let A have color 1, and that doesn't lose any generality. So then we know that B is adjacent to A, and since it's a proper coloring, that means B can't have color 1. So if B can't have color 1, the only other color that's available to B is color 2. And now we are stuck at C. Now we only have 2 possibilities for the color for C, either color 1 or color 2. If C has color 1, as I've sort of drawn it up there, you can see that A and C are both adjacent, and they both have the same color, and that can't happen. If we color C with color 2, then C is adjacent to B, and so they are both have the same color, so C and B are adjacent vertices that have the same color. So no matter what color C is, either 1 or 2, it's going to fail to make a proper coloring. So that means we cannot color the graph G with 2 colors, which means the chromatic number of our graph is 3. So now that you've seen an example, go ahead and work on the activities for graph coloring, and that's on the PDF included with this video.